So in our last lecture, we understood from where the idea of tension and the normal reaction that we draw in our free body diagram, they came. Okay, we know that. And now in this particular lecture, we'll consider this contact force that we draw, and for that we'll do this experiment. So consider there are two blocks, the block number 1 and block number 2, and say these two blocks are somehow joined with each other. They are not in complete contact, just one block and another block is kept near each other. Now say the weight of the first block is 4 kg and the weight of the second block is 2 kg, and on this two block directly a force F is acting. Okay, and this force F that is acting on this two block, say it is 20 Newton. So what force is acting on the block? A force of 20 Newton is acting on the block. Now what does this 20 Newton experience? The 20 Newton says that, hey look, I am pushing an object that is made up of this block and this block. So 20 Newton is right in his own place. He says that since me, the 20 Newton, is acting on a block which is made up of 4 kg and 6 kg, then me, the 20 Newton, is actually creating an acceleration because of this 6 kg. And that acceleration can be easily calculated as A is equals to 20 by 6. Okay, because the 20 Newton says that I'm acting on the entire 6 kg. I'm not acting on one block, but I'm acting on two blocks. And the acceleration is what? 3.3 meter per second. Agreed? Now, something interesting. If the second block were not there, what? If the second block were not there. So imagine there was only first block. So what is the weight of first block? The weight of first block is 4 kg. So in the absence of second block, if on this 4 kg block a 20 Newton acts, what will this 20 Newton say? In this case, the 20 Newton says that I am acting only on the block of mass 4. So what is the acceleration of this 4 kg block? If there were no second block, it is 5 meter per second. So one thing you see it clearly. Here the 20 Newton is acting on the first block. Agreed? The same as the 20 Newton here was acting on the first block. But when there is no second block, this 4 kg block had the power to move with an acceleration of 5 meter per second. But the presence of the second block caused the first block to move with an acceleration of 3.3 meter per second. So somehow this second block, the presence of second block, has decreased the acceleration of the block from 5 meter per second square to 3 meter per second square. Okay, and we know that whenever, so who is actually the person creating problem? Why is the first block moving with a less acceleration now? The only reason that the first block is moving with a less acceleration now is the presence of this second block. So second block is somehow obstructing the complete motion of the first block, and as a result of which the presence of second block is causing the first block to move with an acceleration of 3.3 meter per second. Agreed? So second block is the main problem. Second block is creating huge problem to the first block. Okay, so we all know one thing for sure. Whenever there is a block, whenever there is a problem with motion, whenever there is a hindrance in a good acceleration, the reason for the person who is responsible for causing less motion is also force, because if force is acceleration, if force creates acceleration and force is responsible for causing more motion, then force is actually responsible for causing less motion. So the moment when we see that the first block has the capacity to go at an acceleration of 5 meter per second square when this block is alone and when it is acted upon by 20 Newton force. So when the first block is alone, it can go with an acceleration of 5 meter per second square. But the presence of second block is making this first block to move with an acceleration of how much? To move with an acceleration of 3.3 meter per second square. So the second block is causing the first block to go with less acceleration. So the only reason that the first block is going with less acceleration is because of the second block. And this entire process can be seen as the second block is making the first block slow through a force called as the contact force small f. Agreed? So we talked so much about the first block. What about the second block? Since 20 Newton force is acting, look at this diagram. Don't you see 20 Newton force is acting only on the first block? Do you find 20 Newton force acting on the second block? No. 20 Newton force is acting on the second block. 20 Newton force is acting only on the first block. There is no force acting on the second block. But still, the second block is moving with an acceleration 3.3 meter per second square. Who caused it? The reason the second block is moving is because the force has pushed the first block. The first block is moving and the first block is pushing the second block. It means there is a force from the first block to the second block that is causing the second block move. So two forces are here. One small f towards the left is the hindrance to the motion of the first block by the second block, and another force small f on the second block is the force that the first block has acted on the second block, due to which the second block is moving with an acceleration 3.3 meter per second square. So these hypothetical forces called as the small f, written as small f, these hypothetical forces are natural to explain the motion of this two block system. It is quite natural for us to introduce these hypothetical forces. What is reality? The reality is when you act at 2 Newton force, then block 1 and block 2, they behave as one quantity and they move. But now I am analyzing the entire fact as if the block 1 and block 2 were two separate entity, and I'm trying to understand. So in conclusion, what do we find? So block 1 has the power to move with an acceleration 5 meter per second square, but the presence of second block has caused the first block to move with a less acceleration. It means somehow the second block is creating a force small f which is making the first block move with a less acceleration. And since the second block is also moving with the same acceleration, so I cannot say 20 Newton is acting on second block. You can see directly from the diagram 20 Newton is acting on the first block. So to explain the motion of the second block, I imagine that there is a motion, there is a force by the first block on the second block that is causing the motion or the acceleration of second block. So the birth of this type of forces called as the contact forces that you draw in the free body diagram, or the normal reaction forces that you draw in the free body diagram, is quite natural. So in the next lecture, what we'll do is, now that you have understood the birth of this normal reaction between two blocks, now you know the birth, now we can actually explain the entire motion. So let us do it in this lecture. Let us complete it. Okay. So now that you know that what is the real acceleration, the real acceleration is 3.3 meter per second square. Okay, here is the real acceleration, 3.3 meter per second square. Agreed? Now my main aim is to calculate the value of small f. I want to calculate the value of small f. So I use a very clever trick. The clever trick is as follows. I see that my first block is being acted upon by a force of 20 Newton, and my first block would have happily moved with an acceleration 5 meter per second square if there would not have been any second block. But the reason of second block, the presence of second block, causes the first block to move with an acceleration how much? With a less acceleration of 3.3 meter per second square. So I can say the presence of second block is equivalent to a small force F that has lessened or decreased the acceleration of the first block. So what is the actual motion of the first block? The actual motion of the first block is not caused by the entire 20 Newton, but is actually caused by 20 minus F Newton force. And this minus F is nothing but an indirect. By writing this minus F, I am indirectly putting the information that there is another block in front of the first block. Let me repeat. By writing this minus F in front of 20 Newton is a direct evidence of the fact that there is a second block in front of the first block that is actually decreasing the net force, as a result of which the first block is not moving at 5 meter per second square but is moving at 3.3 meter per second square. So this force, this resultant force, has actually caused the 4 kg mass to move with an acceleration of what? With an acceleration of 3.3. So instead of writing 3.3, can I write 10 by 3? Because it is same. Because 10 by 3 is also 3.3. Because when you evaluate this 20 by 6, you'll get 10 by 3. So for my convenience, I have written this. Now what you need to do is now you need to solve it. So it's very easy. So you have a 20 minus f here, and you have a 40 divided by 3 here. So what will be the value of small f? Small f is what? Small f is the contact force. So easily you can calculate the value of small f as 20 by 3 Newton. So it's the value of small f, 20 divided by 3 Newton. So it's amazing, right? The amazing thing about physics is all about predicting things we cannot see. So this hypothetical normal reaction force has got predicted. We actually were happy. We actually were able to predict the value of this normal reaction force just by using small calculation. This is the beauty of physics. So I now hope that you understood from where this type of small f take birth when you actually study motion, and how to calculate the value of small f trickily by using simple physics equations. Agreed? So we'll discuss more on free body diagrams in our next lecture.